Hi, in this video, we are going to look at a slightly difficult integration problem. It says, let integral from 1 to 2 tan inverse of x square dx be equal to I1. And let's say integral from 1 to 2 of cot inverse x square plus tan inverse 1 minus x square by 1 plus x square dx be I2. Now, they have also given I1 is equal to 2 tan inverse A minus pi by 4 minus 1 over root 2 tan inverse 3 by 2 root 2 plus ln b plus c root 2 by d, and whole of this is to the power half. So this is a complicated looking expression for I1 that has been given. And now the question that is being asked is, option A is I2 plus 2I1 is equal to 3 pi by 2. Option B is I2 plus 2I1 is equal to 3 pi by 4. Option C is A plus B minus C minus D is equal to 0. And option D is A plus B minus C minus D is equal to 1. So basically, you have to find a connection between I2 and I1, and you also have to find the constants A, B, C, D that are present in the integration of I1. When you integrate I1, you will get this long, complicated expression, and there are 4 constants there. You need to find those 4 constants. So first we'll try to approach the first part of the problem and try to find a connection between I1 and I2, right? So let's think about that. So I1 integral for us is 1 to 2 tan inverse x square dx. And if you look at I2, that is also same limits, but now you have cot inverse x square, and you also have plus tan inverse 1 minus x square by 1 plus x square, right? Dx. Now, if you know your inverse trigonometry, you know that cot inverse x square is simply pi by 2 minus tan inverse x square, right? So we can directly replace this and write it in terms of tan inverse x square. The reason we want to do that is because we want to write I1 in terms of I2, right? Or we want to connect the two together. So they should have similar looking terms, right? The other thing that you also need from inverse trigonometry for this problem is this result: tan inverse x minus tan inverse y is equal to tan inverse x minus y by 1 plus xy. This is a trigonometric identity, and here both x and y are supposed to be positive, right? In our particular question, I have an expression like this: tan inverse 1 minus x square by 1 plus x square. So I can clearly see that if you take x as 1 and y as x square, x minus y is 1 minus x square and 1 plus xy is 1 plus x square. So this fits this pattern. So obviously we can say that tan inverse 1 minus tan inverse x square, since both 1 and x square are positive, will fit the formula of tan inverse 1 minus x square by 1 plus x square. So these two concepts from inverse trigonometry are important because then only we can simplify this integral and convert it to the original form. So if you do that now here, you will get pi by 2 minus tan inverse x square plus I get a tan inverse 1 minus tan inverse x square again, and dx, and this is whole from 1 to 2, and that is equal to I2, right? So I2 is equal to integral 1 to 2. This is pi by 4. So pi by 2 plus pi by 4 is 3 pi by 4. And we have minus 2 times tan inverse x square, right? So splitting this integral into two parts, this is 3 pi by 4 integral will be x, and definite integral from 1 to 2 will be 2 minus 1, which is 1, minus 2 times 1 to 2 tan inverse x square dx. And now it is clear that this part is simply I1, right? So what I get is I2 is equal to 3 pi by 4 minus 2 I1. And therefore, I am getting I2 plus I1. I2 plus 2 I1 is equal to 3 pi by 4, which gives us option B. And one of the options is correct. Now we have to validate the other two options. Option A is incorrect, B is correct. Option C and D we still have to find, which is basically finding the integral of tan inverse x square. So for the second part of the question, we have to evaluate I1 is equal to 1 to 2 tan inverse x square dx, and we have to think of what strategy we can use here. Since there is no easy substitution or nothing obvious that we can do using substitution method, I will use the technique of integration by parts here and take 1 as the second function. So when you do integration by parts, the second function is always integrated and the first function is kept as it is and differentiated later. So my second function here is 1. So it will be integrated. You get x tan inverse x square evaluated from 1 to 2 minus 1 to 2. And now you will put a x here and differentiate tan inverse x square, which will give us a 2x by 1 plus x power 4. Right? So you will end up getting a 2x square here, and this part will become 2 tan inverse 4 minus 1 tan inverse 1. So minus pi by 4, right? And this part will become 1 to 2, 2x squared by 1 plus x power 4 dx. So keep this equation in mind. Notice that you have I1 is coming as 2 tan inverse pi 4 minus pi by 4 minus this stuff, right? So in the original question also, we had 2 tan inverse A minus pi by 4 minus some stuff, right? So this suggests that A should be 4. However, we have to complete the whole integral. And now we still have to do the integration of this part, right? Now this is a very standard integral and there is a well-known technique for solving this. If you look at standard textbooks like Arihant's textbook or Cengage textbooks, I'm sure this integral is present in those. So the way you do it is to convert it into two separate integrals, which are easier to do. We can write 2x square as 1 plus x square, or x square plus 1 plus x square minus 1. X square plus 1 plus x square minus 1 is clearly 2x square, and I will write it like this. What is the benefit of this? This splits it into two separate parts. 1 plus x square by 1 plus x power 4 from 1 to 2 plus, and then you have x square minus 1 by x power 4 plus 1 from 1 to 2 dx, right? These two separate parts have similar ways of finding these integrals. So let's do it separately. So we will do integral 1 to 2 1 plus x squared by 1 plus x power 4 first, right? And we'll calculate the value of this integral. The way to do this integration is divide by x square up and down. You will get 1 by x squared plus 1 here, and you will get 1 by x squared plus x squared here dx. This is evaluated from 1 to 2. And here the substitution will be x minus 1 by x is equal to t, because when you differentiate it, you will get 1 plus 1 by x squared dx is equal to dt. So this becomes simply dt by, you can write this as t square plus 2. So the indefinite integral of this would have been 1 by root 2 tan inverse t by root 2. So this is 1 by root 2 tan inverse t by root 2, and putting the limits, you get 1 by root 2 tan inverse, what was t? X minus 1 by x divided by root 2. And now I have to put the limits here 1 to 2. So when you put 2, you get 1 by root 2 tan inverse 2 minus 1 by 2, so that will be 3 by 2. So 3 by 2 root 2 minus 1 by root 2 tan inverse. This will be 1 minus 1, so 0, right? So I'm getting the value of 1 by root 2 tan inverse 3 by 2 root 2 here, right? So we will keep this value in mind, and now we will do the other integral. So I will just write down this value here and rub off everything else, and I will do the other integral, the second integral, which also has to be calculated, right? So let's do that. It will also be done by a similar substitution. The second integral was integral of 1 to 2 x square minus 1 by x power 4 plus 1 dx. And this, by the same method, will divide by 1 by x square. We'll get 1 minus 1 by x square and 1 x square plus 1 by x square. And this time my substitution will obviously be x plus 1 by x is t. And what you will get is dt on top. You will get a dt divided by t square minus 2. So t square minus 2 is going to be basically t minus 2 and t minus root 2 and t plus root 2. And on top you have a 1. So the difference between t plus root 2 and t minus root 2 is 2 root 2. So I can put a 2 root 2 on top and divide by a 2 root 2. And then I can write it as t plus root 2 minus t minus root 2. Whole thing divided by 1 by 2 root 2. Integral with t minus root 2 and t plus root 2. So basically I am splitting it into two different fractions. And what I end up is 1 by 2 root 2. This is going to be 1 by t minus root 2 minus. So it will be ln t minus root 2 by t plus root 2, right? This expression is coming, and now we have to think of what are the values of t, right? When x is 1, your t is 2 when x is 1, and when x is 2, your t is 2 plus 1 by 2, so 5 by 2, right? So the limits are going from here, the limits was for x was from 1 to 2. For t, the limits are 2 to 5 by 2, right? So this is going to be evaluated from 2 to 5 by 2. So you will get 1 by 2 root 2 ln 5 by 2 minus root 2 divided by 5 by 2 plus root 2 minus 1 by 2 root 2 ln 2 minus root 2 by 2 plus root 2, right? This is what we are getting as our expression, right? Okay, now think about this. This I have to simplify a little bit. I can take 1 by 2 root 2 common, and I have ln. This will become 5 by 2 minus root 2 by 5 by 2 plus root 2 divided by the 2 minus root 2 here and 2 plus root 2 here, right? This is my expression. And these two integrals have to be added, and the whole thing has to be subtracted from the values that we got earlier. 2 tan inverse 4 minus pi by 4. So first I have to add these two. So I might as well take a 1 by root 2 common here. So notice that if you take a 1 by root 2 common, the whole expression is starting to resemble the expression given in the question. So I will write it like this. So the answer that we are supposed to get is starting to look like this. 2 tan inverse 4 minus pi by 4 minus 1 by root 2 common And then I have here tan inverse 3 by 2 root 2 plus I have a half and ln. So I can write it as ln of this whole expression to the power half, right? And this whole expression, I just have to simplify and rationalize. I have to rationalize the denominator here, right? So in order to rationalize the denominator, let's do it. Pi by 2 minus root 2, 2 plus root 2. And let's multiply it by their factors. So square, square. And this will give us 25 by 4 minus 2. And here it will get us a 4 minus 2, right? So let's simplify what this comes out to be. Let's see what is coming. So we are getting 25 by 4 plus 2 minus 2 into 5 by 2. So 5 root 2 multiplied by 4 plus 2 plus 2 into 2, 4 root 2, right? This is coming on top divided by, here I get a 25 by 4 minus 2. So that is 8 by 4. So 17 by 4 multiplied by 2, right? So this is becoming a 17 by 2 here in the denominator, right? So 17 by 2, the 2 will go on top, multiply here, and I'll remove the 2 from here. So I will get 25 by 2 plus 4 minus 10 root 2, whole thing multiplied by 6 plus 4 root 2, and the whole thing divided by 17. And now again, simplifying this a little bit, what I end up getting is 25 plus 8 minus 20 root 2, whole thing multiplied by 6 plus 4 root 2 divided by 34, right? And this is 33 minus 20 root 2 multiplied by 6 plus 4 root 2. We have to simplify it and make it look like, we have to make it look like this, b plus c root 2 divided by d. Then only we can find b, c and d, right? So 33 into 6 becomes 180, 198. Then we have a minus 120 root 2. And then we have 4 into 33. So that will become a 132 root 2. And then finally minus 80 into 2. So minus 160, right? So I'm getting a 38 here, 198 minus 6, 38, and a plus 12 root 2 on top. So I'm getting 38 plus 12 root 2 on top divided by 34. Obviously, I can simplify this by dividing by 2. So it will become 19 plus 6 root 2 divided by 17, right? So this is my final expression here after summing up these things. So my B is 19, C is 6, D is 17, and A is 4. So what we get is A plus B is 23 and C plus D is also 23. So A plus B minus C plus D is 0. So that is option C. So we have solved this question now and we have gotten option C. Notice that the calculations were long for I1, but the idea for the integration was not very difficult. Tan inverse x square, how did we integrate this? We did integration by parts. We got this. We got 2x square by 1 plus x power 4. And this integral we did by splitting it as x square plus 1 by x power 4 plus 1 plus x square minus 1 by x power 4 plus 1. In both these integrals, the idea is simple. Divide by x square and take substitution t is equal to x plus 1 by x or x minus 1 by x. And then you will end up getting standard forms, right? So after that, you have to be careful to not make any silly mistake. That is the most difficult part of the question, not making any silly mistakes with the numbers. If you are very careful and precise with your calculations, you will get the two options. The answers are B and C. So that finishes off this problem. I'll see you next time with the next question.